Systems create order by drawing lines. But what if the lines themselves, the very boundaries that define the system, are actually the source of its most predictable failures? This isn't some accident, it's a logical, completely unavoidable outcome of the system's own structure.
You probably have a mental model of how an organization works. You likely see it as a unified whole, right? A single body working toward a common purpose. It's a simple model, but it's fundamentally wrong. An organization is actually a collection of competing parts, each with its own separate logic and incentives. This incorrect assumption is precisely why we so often misunderstand why systems fail. So let's correct it. To see why that model is so flawed, we first have to get really clear on what a system is and how it even establishes its identity in the first place. At its core, a system is just a set of elements that interact with each other according to a set of rules. The key word there is interrelated. These parts aren't independent. They influence one another, and together they create some kind of collective function or purpose. A system really defines itself by what it is not. It draws a line, a boundary, that separates what's inside from what's outside. This boundary is what gives the system its coherence and protects it from the randomness of the environment. Anything inside the boundary is part of the system. Everything else is not.
Let's think about a completely self-contained, automated greenhouse. Its boundary is obvious. It's the glass walls. Inside, all the elements, like the lights, the water pumps, the temperature sensors, they're all interrelated parts of one single system. And they have one goal: grow plants. It is a truly unified whole, interacting only with its inputs like power and water.
But here's the thing. A system can't just stay a simple, unified whole if it wants to be effective. To get efficient at achieving its goals, it has to divide itself.
You see, systems aren't static. They're incredibly dynamic. They run processes, which are really just structured collections of tasks to turn inputs into valuable outputs. A process is simply the sequence of actions the system takes to get the job done.
Way back in 1776, Adam Smith pointed out that the best way to increase output is through the division of labor. You break a complex task into smaller, simpler tasks and have specialized units do them. When you do that, overall productivity just skyrockets. This push for efficiency is a fundamental pressure you'll find in any system.
So, let's go back to our greenhouse. Imagine it now has to grow two totally different kinds of plants with opposite needs. One needs a hot, tropical climate, and the other needs a cool, arid one. To optimize for both, the system gets partitioned. A wall goes up right down the middle, creating two specialized subsystems. Each one is now highly efficient at its own local task. Now, the logical result of all that specialization is something we call an information silo. Each specialized unit starts to develop its own way of doing things, its own language, even its own data, none of which is naturally compatible with the other units. The tropical side of the greenhouse doesn't need to know or care what the arid side is doing, and the other way around. They become insular.
And right here, we hit the core trade-off. By chasing local efficiency, the system starts to sacrifice its global coherence. Each part gets better and better at its specific job, but the system as a whole becomes fragmented and disconnected. The very act of optimizing the parts starts to de-optimize the whole.
Okay, so the system is now aware of its own fragmentation. To deal with this, it does something logical. It creates a new, specialized structure designed for one thing, to manage the friction between its internal parts.
This new structure is called a boundary spanner. Its entire purpose is to exist in that white space between the silos. It's a role, or a mechanism, built specifically to link the organization's separate internal networks and connect them to the outside world.
But this role is so much more than a simple messenger. A boundary spanner has to filter information, deciding what's relevant for each side. It has to translate the goals in the language of one silo into terms the other one can actually understand. And crucially, it has to negotiate how shared resources get allocated, managing the natural conflicts that arise between the two sides.
In our greenhouse, this boundary spanner looks like a complex airlock installed right in that dividing wall. And it's not just a door. It's an active system that manages moving materials, regulates pressure differences, and stops the two climates from contaminating each other. It is the system's official translator between the tropical world and the arid world.
Now, this solution seems perfectly logical. The system saw a problem, fragmentation, and it built a mechanism to solve it. But this is exactly where the deeper, more subtle failure starts to emerge. That mechanism, the one designed to solve the boundary problem, doesn't actually get rid of the boundary. Instead, it just becomes a new, more complex, and far more critical boundary all by itself. The problem hasn't been solved at all. It's just been centralized.
Think about it. Because all communication now has to flow through this one single point, the boundary spanner becomes an information bottleneck and it slows the whole system down. It becomes a source of distortion because it's filtering and translating everything according to its own logic. And it develops conflicting loyalties. It's accountable to both sides, but it's not fully part of either one.
And that airlock, the very thing designed to protect the integrity of the two greenhouse climates, is now the greatest single point of failure in the entire system. If it malfunctions, it doesn't just harm one side. It catastrophically compromises everything, mixing the two environments and destroying them both. The solution has become the primary vulnerability.
This reveals a kind of recursive logic that's inherent in how systems manage complexity. You see, the problem and the solution are actually part of the exact same repeating pattern.
First, a system draws a boundary to create order. But to be efficient, it has to create internal boundaries, and those cause friction. So it creates new structures specifically to manage that friction.
But these new structures are, themselves, boundaries, and they become new, centralized points of failure. The system's attempt to solve the problem of the boundary only ends up creating a new one.
So when a breakdown happens at the boundary between two departments, it's rarely because of one person's error or a single bad actor. It is the rational, predictable, and frankly necessary result of a system doing exactly what it was designed to do: create order by drawing lines. The boundary isn't just where the system breaks, the boundary is the break.